Dear students, welcome to another lecture in quality control. We were seeing about various tools used for quality control. So, of a list of 7, we have finished 5 in the previous lecture. Today, let us see this diagram, which is called as cause-effect diagram. It is also called as Ishikawa diagram. It is named on the person who has proposed this, Ishikawa. Around the 1960s, he has proposed this. Okay, this is a cause-effect diagram, and it is also called as fishbone diagram because by looking at it, it will look like the bones of a fish, with the centrals, the stem, and then branches like a fishbone are there. So in that diagram. So what is this diagram? See, this diagram summarizes the relationships between the quality characteristic and the defects and their causes. Quality characteristic can be, it can be a positive characteristic or a negative characteristic. Now defects is a negative characteristic here. Now if a defect occurs, what is the reason for it? For that, we draw this fishbone diagram. So the name itself says it is a cause and effect diagram. So this is the quality characteristic is the effect, and these things which we are drawing on the left hand side, these are the causes. These causes can be because of anything, like it can be because of the people, that means workers or operators or people who are transporting and other things, because of them, or it can be because of the raw materials and the supplies, or it can be because of the work methods, or it can be because of the environment in which they're being produced, or it is because of the machinery and equipment, because of which these defects are coming, or it can be defects in the measurement. If the measuring instruments are not proper, then it may show that some errors, the defects may crop up, you see. And now here you see there are further branches like this, you see. That means what? The reasons, the causes because of which the defects come, people's causes can be not only one, but there can be many causes. That's why these branches are like this. Similarly, material costs also can be more than one. Okay, so like that, we will see an example in the next slide, and let us see how this this is used. The method of use. This is useful for identification of the factors which affect the quality characteristics, sorting out the relationship between these causes and the results, and representing them systematically. Now if you draw this systematically, you will be able to come to the exact cause because of which this problem, this quality characteristic is being affected. Okay, you see, what is it exactly? See, once if you want to find solution for anything, first you have to pinpoint what the problem is. You have to identify the problem. So this identifying the problem, this fishbone diagram does very well. Okay, so this must be prepared after a thorough brainstorming. Brainstorming means a lot of thinking going, the detailed study about that topic. If you do, sometimes even many people can join together and discuss, and they can brainstorm. and then collecting the opinions of as many people as possible in order to identify all the causes, all the relevant factors which are responsible for this quality characteristic. Okay, now let us see a stepwise procedure for constructing this diagram. See, first is you define the effect or the quality characteristic or the problem very clearly. You see here, there is an example here. See, this is a cause and effect diagram or fishbone diagram or Ishikawa diagram for a manual soldering operation. This is a soldering operation which is manually done, it is not automatic. Okay, and now what is it? Say this is the effect on the right hand side. Okay, as the head is the effect, and all these bones, they are the causes. You see, what is the thing that is the head or the effect? That is, you see, the poor solder joint. This is, manually when you have soldered it, you have detected that there is a defect here. The joint is poor. If solder joint is poor, then what are the reasons why it is poor? Now it can be because of the specification of the solder itself. Okay, and or it can be worker, it can be methods, it can be process, it can be equipment, and it can be materials. So for example, if it is a specification, the defect is arising because of the specification. Now it could be because of the layout of the circuit design, some problems with the layout, or it can be because of the work unit too small for manual operation. The unit is too small, that it, the man cannot, make a fine solder there. See, or the tolerances are too tight. So these are the causes because of this, which are coming because of the specification on this quality characteristic, which is the poor solder joint. And if you take worker, it can be because of worker has missed some joints, or worker has a he is experiencing some stresses of pacing by conveyor. So suppose if it is going on a conveyor and he has to walk beside it, and at the same time he has to solder. You see, because of that, worker is unable to do, or variability of worker skill, sometimes skillful workers, sometimes semi-skilled, sometimes no skill people are maybe working, inadequate training, and all these things. These may be the causes. So similarly, because of method, because of process, because of equipment, and because of material, various causes may be there because of which this poor joint is affected. Okay, so now we are seeing the stepwise procedure. First we have defined this is the problem, poor solder joint is the problem. Okay, then second is mark the short description of the effect in a box. You see here we have marked like defect colon poor solder joint. We have marked in a box. Then draw a horizontal line from this box towards the left. From here, draw a horizontal line. Now list all the possible minor and major causes through brainstorming sessions. See these, which are the minor causes, which are the major causes. List all of them. List in a numbered list or something. And then mark the major causes on the branches and minor causes on the sub branches of cause and effect. You see, specification is the major problem. You see, worker is the major problem, method is the major problem, material is the major problem, equipment is the major problem, process is the main problem. So this is the this is the the branch. Okay, major causes we have we have marked it on the branches. and minor causes, like these things, which these can be marked on the sub branches. Okay, then now look for possible solutions for these causes. You see, this is charting of the diagram. Afterwards, charting the diagram, what you have to do is you look for possible solutions for these causes. Then what you have to do, then you have to introduce the changes. You see, once you have found out what are the solutions, to overcome this problem, you have to implement those solutions. You have to introduce these changes. Then you have to understand the above procedure clearly here. Okay, here a diagram is given. That's what they're saying. Okay, and then next let us see the objectives of cause and effect diagram. Cause and effect diagram, see, the objectives can be to analyze cause and effect relationships, or to facilitate the search for solutions of related problems. It can be to standardize existing and proposed operations, or it can be to educate and train personnel in decision making. You see, in decision making also, you look for so many solutions. Out of that, you choose the best solution and you take the corrective action. Okay, so these can be the objectives and the applications of cause and effect. The application areas, it can be for researching of any topic or something. You can use this cause and effect diagram for manufacturing of a product, for marketing of the products, or for office operations, or for services sectors. Also, you can use this this cause and effect diagram. Now, last tool that we use for quality control is the control charts. There are control charts. Control charts means, this is a chart or a plot, something versus time. You see, some quality characteristic against time it is plotted. See, on the you say, okay, time is taken on the x-axis. Some quality characteristic like the diameter or the length, or the number of defects, or the blowholes in a casting, such things can be on the y-axis. Like that, you control process. You plot control charts, and from that, you will be able to take some decisions for quality control. So what are the methods of using these control charts? Control charts are used for variations or occurrences of defects, deviations from the process, okay, undesirable trends, or undesirable cycles that are coming. Okay, for finding that, you can use the control chart. Actually, about control charts we will study in detail in the coming chapters. Okay, it is also useful for identifying whether the process is in control or not, and for variables X and R charts, or for attributes P and C charts. We are going to study each and everything, like X chart, R chart, P chart and C chart, and all these charts we are going to study. So as of now, you just take it as a tool, and it is called as control charts. Okay, the advantages of control charts, they help in reducing the process variability. They help in performing, for monitoring the performance over lifetime, and they help in identifying immediately if any undesirable outputs, like process out of control or some particular trend. This is actually, if it should be within the specifications. If you say plus or minus 0.02 mm, it should be. You see, suppose it is going towards one side, then we call it as a trend. So that trend can be because of some particular problem in the machine or something like that. That trends can be identified immediately. If you plot these charts, then they help in deciding the quality of outcoming samples of a lot. Okay, so these are the various advantages of the control charts. And now let us see quality function deployment. Now, after seeing the various tools that are used for quality control, now we will come to this thing called QFD. QFD means quality function deployment. You see, it is a process and set of tools which are tools which are used to effectively define customer requirements and convert them into detailed engineering specifications and plans to produce the products which fulfill those requirements. You see here now the customers requirements you take through market surveys or market research. You gather the information. Once you have gathered the information, that customer needs, you see actually here QFD, you see the quality means what is the quality, whatever is the customer is needing or what is customer is expecting, that is the quality. And the function, the quality function deployment, these three words are the quality function deployment. So function means it is the ways to satisfy the customer needs. Now customer is having a need, or customer is having an expectation that I am buying a product and this product should do this thing to me, for me. Okay, see now the function, the word function, that means it shows the ways by which as a company or as a manufacturer you are satisfying the needs of the customer or the expectations of the customer. And deployment means it making it happen through the organization. As making it means again the customer needs or the ways to satisfy the customer needs, that making it happen through the organization. That is the quality function deployment. So the QFD is a discipline for product planning and development. PPD, sometimes I think in some of the places they are having even MTech, the postgraduate degrees in product planning and development, PPD. Okay, because these are all sub branches of mechanical engineering. You can do that. Okay, see, quality function deployment is a discipline for product planning and development in which needs and demands of the customer deployed throughout an organization. You should keep in mind, if you are producing any product or if you are providing any service, this should always be in your mind. Customer is the king. You see, if in olden days when there were kings, what were all the others doing? Oh, they were trying to please that king. You should try to please the king. The customer, the king should never be angry. You see, because if he's angry, what calamity will come upon us, we cannot tell. You see, whose head he will chop, we don't know. We cannot tell. You see, here our customers may not be killing us, chopping our heads, but at least our company can die if customers' patronization is not there. Okay, therefore customer is the king. You see, therefore what you have to do is customers' demands and needs, they should be deployed throughout an organization. Everybody should be conscious of the customer. It should be everything you look from the customer's point of view. Okay, and you design. So the basic idea behind this method is to take into serious consideration the wants of the customer so that they can be translated into engineering characteristics or the specifications, you can say, for that product or service. The QFD team are a group of people who are looking into this function for quality function deployment. This team uses all means to analyze the customer needs. They use all means by which they can analyze the customer's needs and to make specifications which will satisfy the customer. When will the customer be satisfied? When his expectations are met and when his needs are attended to. Okay, the quality function deployment is a research tool and a systematic method which can be used to provide the information needed to help in modifying the products to meet the expectations of the customer. This is one definition for the quality function deployment. So if it can help you transform customer needs into design quality, to deploy the functions forming quality, and to deploy methods for achieving the design quality into subsystems, to deploy methods for achieving the design quality into subsystems and component parts, and ultimately to specific elements of manufacturing process. Okay, so this QFD helps to transform the customer needs into the design specifications, you can say like that. Now the procedure for implementing quality function deployment, it has 4 phases, and these 4 phases are here shown in bold: the product definition, product development, then process development, and process quality control. Okay, say the product definition, this phase begins with the application of the VOC, that is voice of customers. That is, voice of customers means that is the demands and needs of the customer. They are collected through market surveys. Further, these customer needs are analyzed and translated into product specifications. It may also involve in a competitive analysis to evaluate how efficiently the competitor's product fulfills the needs of the customers. You see, you see in the market, no, you're always competing with your customer. Okay, sorry, your competitor. Your competitor is doing a great business, means it is affecting your business. Maybe because they are buying theirs more, competitors more, because your product quality is not up to the mark, or its price is not appealing, or something like that for the customer. So how effectively you have to do a competitive analysis and evaluate how effectively your competitor's product is fulfilling the needs of the customer. And the initial design concept is based on the particular product performance requirements and the specifications. So this phase is called as the product definition. You see, knowing about the customer's needs, requirements, and translating into the specifications. Then the second phase is product development. So during this phase, the critical parts and assemblies of the of the product, whichever you are deploying. So they are identified. What are those critical parts or the critical assemblies? They are identified. These critical product characteristics are translated to critical or key part and assembly characteristics as specifications. The functional requirements or specifications are then defined for each functional level. So in this second phase, the product development, you see all the key parts and key assemblies, they are identified and their specifications are defined. Okay, the third stage is the process development. See, in this phase, the manufacturing of the individual parts and assembling those parts. Manufacturing process and assembly processes are designed on the basis of specifications for the components. Okay, then the process flow is developed and the critical process characteristics are identified. Process characteristics are identified here. Okay, and then finally in the fourth stage, process quality control. See, prior to the production, launching of the production, the QFD process identifies what are the critical part and process characteristics. Part characteristics and process characteristics. Part characteristics we have found out in this stage, in the second phase, and in the third phase we have found out what are the process characteristics. Okay, then process parameters are determined and appropriate process controls are developed and implemented. And in addition, any inspection and test specifications, apart from the routine things, if you have to design and develop, of the testing specifications, you have to do that. And then full production begins only upon the completion of the capability studies or the pilot run or the trial run. Okay, so these are the 4 stages of QFD. Now let us see what are the benefits. The benefits, it facilitates identification of the causes of customers' complaints, from why the customer is complaining, and it makes easier to take corrective remedial action. Okay, then it also helps for improving the product quality. It is useful for competitive analysis of product quality. It stabilizes the quality. It cuts down rejections and rework at the production side. Rework is done when some you detect that a minor change, if you do a little machining here, there, this part which is rejected can come into the accepted lot. Okay, when you do like that, that is called rework. Okay, then QFD decreases the consumer claims regarding service and replacements of the products considerably, and then it minimizes the communication barrier in assessing or clearly defining customer needs. You see, if you're having in your company a team dedicated for the quality function deployment, these people will be clearly defining the customer needs, and they'll over a period of time they become experts in this, and they'll be able to clearly say, if the customer is saying this, this is the meaning of it. Okay, the QFD establishes the link between the product feature and the customer need and the process requirements. Then less chances of product failure due to focus on customer need. Then by evaluation and comparison with the competitors, it provides an opportunity to improve through benchmarking. What I say is, on any problem, if you think for a considerable amount of time, initially it may appear that there are no solutions for this problem, but if you keep on thinking about it, you'll definitely come up with some solutions. You see this is what helps, in teams coming together and discussing, brainstorming, as a team. When you're working, you'll be able to reach those solutions, okay, for your problems. Okay, and then lower development cost. This is another benefit of the QFD. Lower development cost. How? Lower development of cost, because a dedicated team is there, and from the beginning customer needs are kept in mind, and from that viewpoint you are making, so development costs over a period of time may come down, and because of that, lesser price to the customer will have to spend less money. Okay, then if you are taking less money from him, he will be devoted to you. So, okay, this may be a competitive advantage for the success of a new product. Okay, so when you're launching a new product, see, in yesterday's lecture I was telling, man is normally he has a reluctance for change. He resists change. He doesn't want to leave the old thing and adopt the new thing. Okay, therefore, you see, what you should do is you should put your product in the market in such a way that also there is a compelling reason for him to leave his the product with which he is satisfied for so many months and years and come to you. See, for that, this will be a great help, if you are able to produce a thing at a considerable lesser price. Okay, then due to customer focus, the developed product is likely to perform better, because from the beginning, customer was kept in the mind and in the design specifications and everything, and satisfy the customer. So that means about 20 to 50% lesser warranty claims. Okay, then now let us see the applications or the application areas of QFD. Now QFD can be, this methodology can be adopted in various applications like manufacturing of goods and products, or it can be used in service sector also, in software development and IT projects. You see, that's what from the beginning, customer specification, customer needs are kept in mind, and your specifications are all made on the basis of the customer's requirements. You see, in that case, even service sector, software product means, in software IT projects and all these things, this is more like a service sector rather than some product. Okay, it is not it's a tangible product, okay, that they provide. Anyway, business process development area, government, government has so many schemes and other things. So if when they are launching the schemes and everything, if they keep the customer in mind, okay, then they will be able to reach more people, and the people will be happy. People are happy means they will get votes. See, otherwise, no. If people turn their backs on you, you will lose power as a politician. Okay, anyway, healthcare in hospitals and dispensaries and other things, there also you can use this QFD, and environmental initiatives also you can use. Okay, then now in this chapter we come to the last topic. This is vendor quality rating, VQR, vendor quality rating. You see, if you say vendor, who is a vendor? A vendor is a person who supplies you the raw materials, who supplies you these other supplies and tools and machines and other things. These are the vendors. You see, the raw materials. Okay, at least the raw material supplier, will let us call a vendor. Raw materials are processed to manufacture finished goods. Okay, and we are using tools and machines and equipment for that. Therefore, quality of finished products depends upon the quality of the raw materials, tools purchased from the vendors. Okay, so it is essential to evaluate the quality of the sample products that we are receiving from the various vendors. You see, the vendor, that means the supplier who is supplying the raw materials or the tools, we have to rate him. Why we have to rate him? We should know who is a good vendor and who, you see, when you're saying good or bad, very broadly we're saying, okay, the good, bad, that is a way of rating the vendor. Okay, vendor quality rating uses various formulae, because over the period of time you are doing the same thing and again, so you will find means by which some calculations, mathematics and formulae and other things can be brought into this field also. So therefore some formulae come. Okay, vendor quality rating uses various formulae to obtain the quantitative measure of vendor quality. Quantitative measure means you can rank them between on a scale of 1 to 10, where this vendor stands. Oh, this is that, or you see, as online shopping, you would say star rating. This is a 5-star thing, this is a 1 star only, this is 3 star, this is a rating. Okay, that way we are going to rate the vendors. So that is vendor rating. In broad sense, vendor quality rating is defined as the procedure to evaluate the ability of a vendor to meet quality requirements, how he is able to provide quality products to us. Okay, on the basis of that we are going to evaluate him. Evaluation means we are going to give him marks. Okay, these ratings are used to select the best vendor amongst all the vendors who are ready to supply their products to our company on the basis of comparison and reviews. Okay, why what is the necessity for vendor rating? You have to measure how well each vendor is doing and quality wise, and you have to compare various vendors to judge performance of each vendor for some period which can be extended if required, and then to eliminate the vendors if they are somebody is doing badly over a period of time. You have to eliminate him also. So for that also you need vendor rating. And the vendor rating, uh, you know only vendor quality rating alone is not sufficient to make decisions. So just on the basis of quality you cannot, because price also matters. If he is giving discounts or something, he is whether he provides some delivery on time or not, he delivers on time or not, and what are for other services he offers, what is the capability to supply the required quantity in the stipulated duration. All these things also we have to consider, not the vendor's quality rating alone. You see, vendor overall rating you should see. Just quality is not sufficient, because money also you have to consider. Other factors that we have listed here also should be considered. Therefore, vendor rating plans, now here there are plans. Okay, vendor rating plans, they are developed by the officers working in the purchase department. So these purchase department people, who are purchasing the things from the vendors or the suppliers, they will be using some vendor rating plans. Now you may say, what are these plans? Now some 3 plans are listed here. Okay, anyway, these officers are responsible for taking the purchase decisions considering all the above factors. So therefore the company is benefited on purchasing of the items, and they are purchasing good quality items and at lower rates. Okay, different vendor ratings can be categorical plan, like I said, good, bad, and you can say just plus, minus, neutral, the categorical. You see, weighted plans means on a scale of 5 star, 5-star rating, or here they are saying, so from 0 to 50 you can rate. This vendor, in our rating is at number 50, or he's at number 40, he's at number 30. The moment you say, you will understand, oh, this is the thing. You see, like we are saying, oh, this student scores 95 marks, 95% marks, this student gets around 60% marks. That is how the rating of the students is done. Similarly, on the vendor rating also is done on the same fashion. Okay, that is a weighted plan. You see, like on the basis of marks, or on the basis of some weightage of points. See, that is the weighted plan. Then third one is cost ratio plan. This plan compares the vendors on the total cost in terms of money for a specific purpose. You see, cost basis. Total cost includes price quotations, quality cost, delivery cost, service cost, and all these things. So these are the different plans. Okay, so with this we come to the end of this chapter. Actually, in our units there are only 5 units. 3 units are for industrial engineering and 2 units are for quality control. But in your textbook, what they have done is, say the industrial engineering is only, they have given in 3 chapters, but the quality control, those 2 units they have distributed over 4 chapters. So therefore now what we are having is, we are having the chapter number 4, 5, 6, 7 for quality control. So now till now what we have covered is the chapter number 4 we have finished. But still there are 3 more chapters to come. Okay, so from the next lecture onwards we will go to uh, the the fifth chapter. Okay, okay friends, then today we'll stop here. Thank you.